Here I'm going to solve this system of linear equations using Cramer's rule. So the first thing I need to do is to make sure that each one of my equations is in standard form, which it appears that they are not in standard form. So I'm going to have to kind of rearrange the terms a little bit in order to enforce that standard form rule before I can grab my values. So it needs to be x and a y on my left side in that order, and then equals my constant, which means I need to take this 2y and I need to dump him right there. So that will be 3x minus 2y equals 5. Because when I take the term from one side of the equation to the other, I'm going to go ahead and change its sign, so from positive to negative, hence the subtraction sign. On the right side, I need the 6x to be dumped over here in front, so it'll be negative 6x plus 4y equals negative 8. So this will be my system kind of rewritten here, which now I can go ahead and grab my values, a, b, c, d, e, f. So once I have those written and found, I can go ahead and implement these formulas for x and y. So for x, I need b, c, e, f. So b, c, e, f. So that'll be negative 2, 5, and 4, negative 8. And my denominator, DEAB, so DEAB. So negative 6, 4, and 3, negative 2, which I know that the denominator for my y will be the same. So I'm going to go ahead and rewrite that now here. Okay, so I'm just focused on my y numerator now. DFAC, DFAC, so negative 6, negative 8, and 3, and 5. Okay, so let's go ahead and start working these determinants. So negative 2 times negative 8 is 16 minus 4 times 5 is 20. So I have negative 4 on top. My bottom will be negative 6 times negative 2 is 12 minus 12. Oh, that's going to be 0. So my determinant of my coefficient matrix is 0. So I know that this system will not have a single point of intersection. So that means it's either going to be dependent, which means the lines are coincident, or it's going to be inconsistent, which means the lines are parallel and they never cross. So let's go ahead and finish up this y. So negative 6 times 5 is negative 30 minus negative 24. So when I add that, that'll be negative 6. So because my coefficient matrix had a determinant of 0, and because neither of these numerators was 0, I know that this is going to be a system that has two parallel lines. So these lines are never going to intersect. So what I write, the solution then for this system is in fact no solution, because the lines ultimately are parallel and never cross.